Hello, College Algebra student. This video is for Chapter 6.3, Logarithmic Function. So log function. So what is a log function? It is actually the inverse of exponential function. You would still remember log functions are basically two forms. There is either growth like this or decay like this. And by looking at the horizontal line test, you can see they are both one-to-one function. Any one-to-one function would have an inverse. So we would find this inverse and we call this a log function. And the way to write this log function would be instead of, usually we say, oh, if it's a polynomial function, it's a square, then the inverse is square root. But we can do x root, right? Because x is actually a variable. So although this is an exponent, and when you do an exponent, the reverse is a root, but because the base is actually constant, the x is changed, the x, is a variable. So the inverse actually is called log base b, log base b. Now this is the name of the function. The b here has nothing to do with the x. The x is the input to the log function. Okay, so they are separate. So log base b is the name of this function, is just the inverse of b to the x. Then because there's inverse, so the input to the log is actually the output of b to the x, and the output of log b is x. Namely, if I have an input x, I put it into b to the x function, the exponential function of b to the x, my answer would be b to the x, right? This is the input, and this is the output. So what inverse say would be, inverse would take this answer of an exponent, put it into the log function, log base b function, and then you would have x as the answer. So basically you would have something that has been exponent with a base. After you put it in here, this is the y, you will get the x back. So you can say log is the one that extract the exponent from a number with the base b. So then an example would be, okay, so I have exponential function of 2 to the x, right? If I do 5, start of x equal to 5, I do 2 to the x, I would have 32, right? So then I would have a log function, log base 2. If I put 32 here, my answer would be a 5. Log base 2 of the answer of an exponent, which is 32, it would give me 5. So you would say, okay, if I input log base 2, 32 is my input, my answer is 5. Okay, so that's how you understand log function. Log function reverse your exponent by extracting just the exponent with the base you specify here, right? So if I have an exponential function is 2 to the x, the log base 2 function is called log a small number base 2x here. Okay, so if another would be if my f of x is 5 to the x, then my inverse function would be what? Log base 5, which is a name, and x. Y equal to log base 5 to the x. And if I have a decay function, 1/3 x, 1/3 to the power x, then my inverse function would be a log function. Log, what is the base? The base is 1/3. That's just a name. I still have x, which is the input, which is 1 or 1/3 of the something, those things. That is equal to y. Okay. So just remember the log base 2 here is not an exponent. It is actually the name, not 2 to the x. So this is what I talk about. Yeah, if I have 2 to the 5 equal to 32, then log base 2, 32 equal to 5. Because the original exponent function has input 5, output 32, The log function has input 32, output 5. So that's what I was talking about here. So in general, we would say if I have an exponential expression, b to the x is equal to y, that means if I do the same base, so remember this determines the base, the name of the log. Log base b, I put this answer here inside, I would get the exponent back equal to x. Because in exponent, this is xy, right? Input, output, xy, x comma y. And for inverse, we have yx, right? So I would switch. So this become y, this become y. So it become here. So this is y comma x. So your log base b, your output, would equal to x. Okay. Another thing that you need to know is we talk about base being b, it could be any number. In special case, when e is the base of the exponent, then our log base e is known as natural log, and sometimes we abbreviate it as ln, natural log. So if you see ln x, that means it's log base e. Log base 10 is known as the common log, and it's written as log nothing x. So if you see log with no base, that means log base 10. Okay, if you see ln, that means log base e, and it's also known as natural log. Log base 10 is common log. So the first thing we want to do is to, if someone give a log function written as log function, write the equivalent exponential notation. Okay, so this was the output and this was the exponent input. So their base is 3. So first you look at the base. 3 to the, what was the exponent? The exponent is here. Because this is log xy. Now you have yx. Okay. So another one is the base is 1/2. Your input is 8. Your output is -3. So you will say 2 to the power -3 is equal to 8. Okay. They are equivalent expression, but just written in different way. One is called the log notation. This is the log notation. This is exponential notation. So my base is m. The exponent was k and equal to x. So xy, yx. Got the idea? So now I have log t equal to g. So what is the base? If they don't write anything, the base is 10. 10 to the power what? 10 to the power of the answer, because this will give the exponent. G is equal to the inside t. So again, x, y, yx. So they are inverse, so the x and y switch. What about ln? If I have ln, the base is e, and the exponent was the output, right? So t is equal to 8. Okay. There, again, this is the input of the log, and this is the output of the log. It becomes the input of the this becomes the input of the exponent. So input of the exponent is in the exponent, and that's the answer. The answer is inside. So what about if I have the other way around? I write a log notation, x to the 3 equal to 512. So how can I write a log notation? So first of all, I have to determine the log name. It's log base 8, right? And what is the input? The input is always the output. Earlier we say log to 32. So we want a big number that has been exponented. And then we would output back the original exponent, 3. Again, x, y is yx. Okay, so a log base what? Base 36. What is the inside? So its inside would be the output. So would be, oh no, yes, 36. So it would be 6. What is the answer? The answer is the exponent. Again, this is x and this is y. So we have y and x. X is 1/2. Again, what is the base here? Is base b. So I would say log base b. The answer was p. So I would say this is my input now, and my output is the exponent 7. Again, one more. If I have e to the third equal to b. So that means my log is ln. I input the answer b, and I get 3. Is it 3? Oh, no, this is a. It's very small. And then the last one, my log is what? Log base 10. I don't write the base. I just say that the input is the output of the exponent, which is s, is the answer, and then it is the input w. Oh, the last one. We know b to the anything is 1, right? No, b to the 0. Any b is to the 0 is 1. So if I write it as a log, I would write log base b, any base. The inside is this answer, which is 1, is equal to 0. So this is something that is good to know. Log base of 1 is equal to 0. Log base of 1 equal to 0. So that is how we understand log. Log is the inverse of exponent, and you can use it to rewrite equation in log and exponent form, and you can also use it to evaluate exponent and evaluate log. So if someone write an expression log 2 of 16, do you know what it is? So you can think of it as, okay, they are giving the answer, right? So that means 2 to the something is equal to 16. What is this something? So you will say, oh, I know, if I multiply this 4 times, it's 16, so this is equal to 4. So actually you would think 2 to the this equal to 16. So 10 to the answer is equal to 100. 10 to the what equal to 100 is 2, right? And then the third would be 7 to the what equal to 17. The one symbol have 17 is a reciprocal, so it's -1, because 7 to the -1 is 1 over 7. Again here, this is a log notation, and the base is 2, so I say 2 to the what, because this is the input, this was the output, now it's the input. So 2 to the exclamation mark equal to 18. 2 multiply how many times equal to 18? It's 3 times is 8, but 1 over means -3. Right? Because I know 2 to the 3 equal to 8. So this is not, it is 1 over, so it has to be -3. What about this one? Log base 5, so that means 5 to the what equal to the inside square root 5. And we know the definition of square root is a 1/2, right? 5 to the 1/2 is a square root. Last one, ln. ln means the base is e. E to the what equal to the inside. E to the 3, of course, that's equal to 3, right? 3. And I think I made a typo, so it'd be log 1, right? Log 1 is what? So this is question mark. So that means 10 to the, so this is the base, 10 to the what equal to 1. Of course, 10 to the 0. Okay, that's a typo over there. So we have another set of question, which is solving for x, and also evaluating some x value. So can I finish it? So let's go through. Can I finish in 2 minutes? I don't think so. So maybe I'll do another video, okay, to go through how to solve the x if the x is unknown here.